Okay, so let's take a look at our circuit and see what we know. So I see this. I'm just going to write down some stuff. Haven't done this in this problem in a year, so I don't remember how it works out. I see that V plus is 5 volts because it's got a 5-volt voltage source there, so I know V minus has to be 5 volts. I don't like current sources, and I see there's a current source in parallel with the resistor, and I am going to change that to an equivalent voltage source. So the way you do that is just use Ohm's law. So 2 milliamps times 4 kiloohms is 4 volts. So 4 volts plus or minus and then that would be in series with a 2 kiloohm resistor. So that is source transformation, where you change a current source to a voltage source or vice versa. The resistor stays the same. The voltage source you get from V equals IR. You don't have to do that. The problem works out the same if you keep it with a current source. I just have an anti-current source bias.
No current, well, it's really transferring from one place to the other because of that node, right?
Probably. I haven't actually looked at it yet, but you're probably right. There is going to be, we can't have any current going into the op amp. So let's see. So we know that this current is 0 and this current is 0. So we know that we have current. We have current coming here, and the current breaks up and goes here and here, but then no current goes into the op amp. So the 6 kiloohm and 6 kiloohm, these all of the current that goes through the 6 kiloohm also goes through the other 6 kiloohm resistor, because none goes into the op amp. So let's see. I will call this node V1 and this node V2. And I'm going to do some nodal analysis. So I'll say V1 minus 4 over 2 plus V1 minus, the voltage right here is V out. V1 minus V out over 4K, these are all K's, 4K, plus V1 minus 5 over 6K. So I got this current, and this current. So V1 minus 4 over 2K plus V1 minus V out over 4K plus V1 minus 5, because V2 has to equal 5, over 6K has to equal 0. And then at V2, I'll have V2, which is 5, minus V1 over 6K, plus 5 minus V out over 6K equals 0, because I don't have to do the current going down because that's 0. So I did the current going this direction and the current going this direction, and the current going down was 0. So I'm not going to do a separate equation for V out because I don't need to. I already have 2 equations and 2 unknowns. So I'll multiply this top equation through by 12k. And, oh wait, is this one going to help me? Multiply the bottom one through by 6k. Let me do this bottom one first, because it looks like something good might happen. V minus V1 plus V minus V out equals 0. Oh, no, not terrible, but I was hoping I would get that V1 equal V2, but my 5s don't cancel. I get that V1 plus V out equals 10. Okay, so I do have to deal with that top equation. And when I multiply through by 12k, I get 6v1 minus 24 plus 3v1 minus 3v out plus 2v1 minus 10 equals 0. That's where I'm most likely to make a mistake, so let me check that. Oh, I probably still made a mistake.
Would the 6v1 be 6k?
No, because the k is going to cancel. So I can't, the k's cancel every.
Oh, yes, it would. Yeah, it would. Okay.
So then I get, that was a 2v1. So I get 6v1 plus 3v1 is 12v1 plus 2v1 is 14v1 minus 3v out equals 34. Maybe? And then V1 plus V out equaled 10. And this one would not be that bad to solve since that second equation is pretty, but I'm going to have to get out a calculator eventually, so. That's right. What were my numbers? (14 minus 3, 34). And 1 and 1 and 10. No.
What's the answer?
The answer is V out is supposed to be 5.24. I mean 5.42. Let's see where my mistake is. Let's see. V1, 2K, 4K, 6K. 4K with V out. Uh, 17. I'm missing. V1 minus 4, V1 minus V out, V1 minus 5. Vn minus V1, Vn minus V out. Where did they get 17? That's 6, that's 24. That's 2, that's 10. It's 34. 14 minus 3, 34. Did I add correctly? 9. I did not add correctly. 6 plus 3 is 9, not 12. So that should have been 11. 6 plus 3 is 9, plus 2 is 11. There's the right answer. Okay, so V1, which we didn't need, is 4.57, and V out is 5.42. So my mistake was right here. 6V1 plus 3V1 plus 2V1 is 11. So V out is 5.4 V2. I believe that's what it asked for. Yeah, to find that value. So the problems with the op amps are they're the same kind of problems that you've done. You just have to apply the properties of the ideal op amps to figure out, to be able to get to your answer. Okay, so any questions before I wrap this up? Any questions?
I think that covers anything that I had confusions on.
Okay, great. Yeah. So and again, this last problem we did is, if you can get that, that's going to be probably as hard as anything that you would get with an op amp.
Actually, I just want to make sure. So the way we converted that 2 milliamps to the 4 volts was through Norton?
No, kind of, yeah. It's the same idea as Norton. It's given in your book as source transformation, and so that's what you'll usually see it written as. But it is the same. It is the same as Norton, and so yes, that's actually a good way of thinking about it.
Okay.
So
I just want to make sure.
Yeah.
And it's just because of the fact that you multiply the two together and then you move it up into series with itself.
Right, and that is, it's because they act the same, which is where Norton comes from anyway. So you'll often see it listed as source transformation, but getting the Norton equivalent of it is a good way of thinking about it. If we had not done that, then we couldn't have done nodal analysis, and we would have had to have done KCL, and
It would just get real messy.
I think so, yeah.
Okay.
All right.
That's it.
Okay, that's it for today, and I will see y'all Tuesday. Bye.